Time to do an example of a Karnaugh map with don't care entries. You can see here that we have a truth table, and there are two don't care entries in the Karnaugh map. There's one here in the second row and one here in the seventh row. Our job then is to, first of all, draw the Karnaugh map, fill it, group it, write the equations, and then probably draw the logic circuit depending on how complex it is. So we're going to go ahead and observe that there are three variables, A, B, and C. So it's going to be the rectangular version of the Karnaugh map. It is typical for three variables. It just takes a little bit of time to sketch it here, but of course, once you've done this a lot, it gets to be pretty easy to fill it in. Don't forget 1, 1, 1, 0, and then here's 0 and 1. I'm going to fill in the corners here. Okay, then I'm gonna take these in groups of 4. So I see it's 1x 0 1. So I put in 1x 0 1, and then I see 1 0 x 0 1 0 x 0. Okay, so when you're faced with a problem like this, there's often a little bit of time when you're looking at it and thinking, okay, I could group 4 and 6, I could group 0 and 1. Eventually, though, I come to the conclusion that the best grouping would be this one, where I'm going to group those two across the edge, and then I need to group cell number 3. Cell number 3 can really only group with cell number 1, and since cell number 1 is a don't care, that's just fine. So notice then that we're treating cell 1 as a 1, and we're treating cell 6 as a 0 because we're not covering it. So then if I wanted to write this equation, I would write F is equal to, let's do the one in the top row that has B equals 0 in common, and it has C equals 0 in common. So this would be not B and not C. Or, and now the one in the bottom row that has not A in common, and also C in common. So this is not A and C. So I believe that that's the equation, and then it's not too hard to see that we're going to need to have two AND gates, each of which is going to have two inputs. Those will both feed into an OR gate. I can see that the term C is used in both of these, so I'm going to put C in the middle. So I'll put A here. A needs to be inverted, and that'll go into this input. Down here, B needs to be inverted, and that'll go into this input. And then C needs to be inverted, and the inverted one is going to go with B, so that'll be down here. And then the uninverted one is going to go with A bar. So there's the equation and the function, or the digital logic circuit that is used to implement that truth table with the minimum sum of products expression. Now we get a bigger one. So this is a 4-variable Karnaugh map. So I'm going to go ahead and sketch that out. So I'm going to have 4 variables here. And so I'll write A and B across the top, and then C and D down the side, 0, 0, 0, 1, 1, 1, 1, 0. That gray code should become second nature pretty quickly. 0, 1, skip down to 2, back up to 3, 4, 5, skip down to 6, back up to 7. Skip a column, 8, 9, down to 10, back up to 11, 12, 13, skip down to 14, back up to 15. Now I'm going to take these in groups of 4. So I have 1x, x1, 1x, x1. And then I have 0, 1, 0, 1, 0, 1, 0, 1. Then I have 0x, 0, 0, 0x, 0, 0, and then 0, 1, 0x, 0, 1, 0x. Okay, looking at this one, it's clear that I need to have something toward the left edge that's going to cover cells 0 and 3. So I'm going to go ahead and take this column here. Again, I always do this in pencil when I'm not doing it on a tablet, so that I can erase the groupings if I discover later on that I've made a bad mistake. I need to group cells 5, 7, and 13. I think definitely the easiest way to do that would be this square in the middle here, which means that I'm treating cell 15 as a 1, I'm treating cell 1 as a 1, I'm treating cell 2 as a 1, but I'm treating cell 9 as a 0. So then I can write out here F is going to be the sum of two products. The first one is the first column, so that's not A and not B, or, and now I need to take the middle of the entire K-map, so that's going to be, what is it going to have in common? It has B equals 1 and then it has D equals 1. So it's B and D. And so once again, I'm going to have two AND gates. Those are both going to feed into an OR gate. And two inputs on each of those AND gates. B is common between the two, so I'm going to go ahead and put B in the middle. And B needs to be inverted. Up here, this will be A. A needs to be inverted. And then the inverted version of B goes with the inverted version of A. Then I need D, feeds directly into here, and then B feeds directly into here, and that's the complete solution.